Hi, this is Tarik Rashid, another class, and this class is about artificial bee colony. This is part one, and part two will be a practical part on how to use this algorithm. So, uh, artificial bee colony or ABC was inspired by intelligent searching behavior of honeybees. This is kind of a swarm-based Meta-Heuristic algorithm, which is presented by Dervis Karaboga in 2005, and it was used for optimization problems. The algorithm is precisely based on the model presented by both Tereshko and Loengarov in 2005 for the searching behavior of honeybee colonies. ABC uh, is a nature-inspired algorithm. It has three essential elements: employed and unemployed foraging bees and food sources. Both employed and unemployed foraging bees would search for the third element, which is searching for the food sources close to the hive. ABC also defines two important styles of behavior, which are essential for the self-organizing and collective intelligence. The first one is recruitment of foragers for rich sources, producing in positive feedback. And the second is abandonment of poor sources by foraging, producing negative feedbacks. Agents or solutions of the colony of artificial forager bees try to find for richer artificial sources, which are good solution for given problems. In ABC, the problem is reformulated as an optimization task to find the best parameter vector that minimizes fitness function. ABC starts by generating an initial set of random solutions or individuals or agents, then iteratively, repeatedly improves them using neighborhood search strategies. During this process, better solutions are refined and found, while poorer ones are gradually kicked out or ignored. Now, it has three types of bees, this algorithm: employed bees, onlooker bees, and scouts. Scouts bees initially search randomly for food sources, while employed and onlooker bees exploit and evaluate these sources. Over time, food sources become exhausted, promoting scouts to search for new ones. And when an employed bee exhausts its food sources, it becomes a scout bee and searches for new food sources. In ABC algorithm, each food source represents a potential solution, and it is nectar corresponds to the fitness function or utility function that it has. The number of employed bees equals to the number of food sources, with each bee assigned to one solution. Now, this is the kind of representation of here the initialization. So initialization, the algorithm will start to initialize a population of food sources. Each food source will represent a possible solution. And then here is employed bee phase. Each employee bee explores a food source and searches for a new one in its neighborhood. If it's a better, then it keeps it. If not, then it replaces it with the old ones. And here we have uh, here we have onlookers. Onlookers bees watch the dance of employed bees. They choose food sources with a probability proportional to their nectar amount, or the fitness that we call it. And then they search for new solutions around the selected sources. And then we come to the stage number 4, which is scout bees. These are scout bees. If a food source cannot be improved, then it will be neglected after a limited time. And then scout bees will be randomly generated to replace those food sources that they are not improved. They're not improving. And then the termination is here. That's the termination. So that's the cycle of it. And this is the algorithm. So start, initialization, and then employed bees, bee phase. Here they explore food sources, and then they come to the onlookers. Onlookers bee choose the food source based on the probability and explore them. And then we have scout bees. We say that if the food source is not improved or cannot be improved, then the scout bees will be generated. The cycle will be repeated. Here, if the convergence is met, we'll come to yes, we'll terminate. If not, then we'll go back to here to step 2, which again, employed bee phase, which they explore the food source. So that's more or less about this algorithm. Equation 1, here we try to get scouts, I mean the initialization of the population and lower bound and upper bound for each dimension. And here employed bees, they try to find a neighbor food source, which is VM. This VM and this is random. So here the employed bees, they try to get better food source or discover a neighbor food source and then estimate its productivity of fitness. So this is equation 2, will be used for that. There are some parameters we can, in the next video, we give you a practical example and then we will be able to understand how to implement this algorithm in a practical way. Here is the function for kind of the fitness function to value the solution. And if here the fitness function is based on a problem whereby it looks for minimization of solution. So the food source VM is produced and its fitness can be computed. Kind of a greedy search will be selected when we create VM and we have XM. Then this is we check which one is better. It will be a greedy selection. And here that would be the function for the fitness. And then onlooker bees, unemployed bees include onlookers and scouts. Employed bees share food sources information with onlookers, who then probabilistically select food sources based on the fitness function. And here is the equation for how the selection probability is computed for the onlooker bees. Now, more or less about this one, we have scout bees. Scout bees, when the food source cannot improve, then the user has a limit to use the food source. If it's no improvement in it, then scout bees will be randomly initialized using equation 1. So if we go back to the equation 1, here we can get the scout bees from here. And now here we can get we define a neighborhood source via VM through this equation. And that's for probability selection. So that's more or less about this algorithm. Stay tuned for the practical part of this algorithm. We will give you example how to solve a problem using a BC artificial bee colony. Thank you very much. Stay tuned.